Hi, this is Mrs. Cat, and I'm here to help us finish up our compounds 3 levels diagram. So at this point, we have talked about Avogadro's hypothesis by looking at worksheet 2 in unit 4. So we're going to add that to our 3 levels diagram in the particulate space. So I'm going to start by dividing up a new space underneath our diagram of water. And we're going to add in Avogadro's hypothesis. So we're going to want to start with some pictures. Okay, I'm going to show the formation of water vapor as our example. So I'm going to draw in some boxes to represent my volumes of hydrogen that are going to combine with my volume of oxygen to form my 2 volumes of water vapor. Now, I'm not doing an excellent job of making these volumes look equivalent, but they are meant to be. Okay, so I'm going to use 2 particles per box just because I don't have a whole lot of space due to their size. And remember, in Avogadro's hypothesis, we want to show that these 2 volumes of hydrogen and 1 volume of oxygen are going to give us 2 volumes of water. And the only way that that's going to be possible is if we have 2 atoms of hydrogen and 2 atoms of oxygen in each of these. Now, let me label this as water vapor. I do want to specify it's water vapor because we know it's going to be a gas. I'm going to go back in and add in the fact that these are gaseous. We want to show that they have equal temperature and equal pressure. So I'm going to give the same number of whooshies and same number of whammies in each box. I'm going to do 1 of each. Okay, so we want to make sure that we are showing that mass is conserved. And that there are the same number of each type of atom before and after. Okay. We also want to show that gas laws are being followed. This is because we have the same number of particles. So I'm going to use n because that's our variable for that. In equal volumes. And we have constant temperature and pressure. Went out of the box a little bit. That's okay. Okay. Now, last thing we want to show here, which is what Avogadro's hypothesis is that hydrogen and oxygen are diatomic elements. Remember, there must be 2 atoms in those elemental gases to make this happen. Okay, the 2 volumes of hydrogen and 1 volume of oxygen create 2 volumes of water vapor. Now remember, we've seen this happen through the separation of the water vapor, okay, in our lab with the electrolysis of water, and it's also going to happen in opposite directions, right? Aside from, or along with hydrogen and oxygen, there are 7 total diatomic elements. We want to make sure that we write those down because those are going to be important. Okay. There are 7 diatomic elements. And those are bromine, iodine, chlorine. Oops, actually, I'm going to add another one in here first before chlorine. Bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. Now, there's a reason I went back and added nitrogen in earlier, and that's because I like to use a little mnemonic device, and that's Brinkelhoff. If we say all of these 7 diatomic elements in this order, it sounds like a silly word or a silly name, but those are our 7 diatomic elements. These are the ones that are going to follow Avogadro's hypothesis and have 2 atoms bound together for every 1 particle of these atomic gases. So that'll do it for our 3 levels chart for compounds, and that'll also do it for us for Avogadro's hypothesis.